Start.
Uh, okay, sir. Myself, Dr.Sada A.Kanade from J.S.M.College, Alibag. I'm working in J.S.M.College from 2016 6 as assistant professor, and recently I have accepted uh, the responsibility as IQSC coordinator. Now I will thank Vijay Lakshmi Vishwanath Davi College for giving me this opportunity to engage this lecture. Okay, thank you. Now we'll start our lecture. I'm going to discuss on electrical properties of metals, that is free electron theory. Basically, before starting the theory, it is necessary to know the important properties possessed by the metals. Uh, Now, in everyday life, we are using many metals like iron, steel for daily uses, like gold, silver, etc., as a jewelry. Now, each metal has its own importance in our day-to-day life. Now, these metals have their importance in our day-to-day life because of the various electrical properties and also the mechanical properties which the metals can show. Now, let us discuss some of the basic properties of the metals and then we move to the uh, theories of metals. Some physical properties of metals are, first of all the metals will obey Ohm's law. Now, as a student of physics, everyone is aware of Ohm's law, that is, provided the physical conditions of the metals remain same, the current is directly proportional to the applied voltage. Okay. Now all the metals will obey Ohm's law. Now the second property of metals is all the metals have high electric and thermal conductivities. That is, they are very good conductors of heat and electricity. The resistivity rho at room temperature is of the order of 10 raised to minus 7 ohm meter. That is very small resistivity above a temperature called as D by temperature, and that resistivity is a function of temperature. Resistivity is directly proportional to the absolute temperature. That is, above a temperature called as D by temperature, resistivity is directly proportional to the absolute temperature. But for temperature below D by temperature, that is at very, very low temperatures, resistivity is proportional to fifth power of absolute temperature. Okay. Uh, Next, now resistivity is a inverse function of pressure. Means for metals, if you apply pressure, the resistivity will varies inversely as pressure. That is, metals will show piezo-resistive effect. Similarly, metals will show magneto-resistance effect. That is, if you apply magnetic field to the metals, their resistance will change. Similarly, metals will obey Matthiassen's rule, which states that the resistivity can be expressed as sum of two terms, that is resistivity due to impurities present in the material. Now impurities means some unwanted materials which are present in very small quantities are called as impurities. Now among them, this part, the resistivity due to impurities, is supposed to be the constant, because the origin of resistivity is the collision of electrons with the ions. Now impurity atoms are very small in number, and therefore variation of resistivity due to impurities present is supposed to be very, very small, or it is constant or independent of temperature. Now in the second term is a resistivity dependent on temperature, which is due to the interaction of electrons with the lattice. While motion of electrons will collide with the lattice, and because of that, the resistance will arise. Now, as the temperature rises, the collision will increases, and therefore the resistance will increase. And therefore, the total resistance is function of two parameters. That is a constant term, which is resistivity due to impurities or imperfections, and the second term, a temperature dependent resistivity, which is due to the lattice electron interaction. Nextly, the metals will obey Weidmann-Franz law, which states that the ratio of thermal conductivity to electrical conductivity is a linear function of absolute temperature. Okay, that is most of the metals will obey Ohm's law. म्हणजे आपण जर कन्सिडर केलं तर मेटलचे काही प्रॉपर्टीज हे आपण बघतो. ह्या मेटल्स ह्या सगळ्या प्रॉपर्टीज ओबे करतात. नाउ वी आर शिफ्टिंग टू द theories of electron. Basically, I am discussing with the free electron theory. First, we start with the classical theory, and then, if possible, we will extend to the quantum mechanical theory. Now, why it is necessary to discuss though the classical theory, even though if it is not used or it is failing in many of the aspects, is a question. Now, when we are dealing with any materials or any theory, if we know the theory or the phenomena by which we can explain the properties, now if you want to change these properties as per our requirement, the theory which is responsible for that properties to be known. Okay, now metals will show very good electrical conductivities. Now, to explain that, the first theory is proposed by Drude in 1900. In 1897, J.J. Thomson has discovered electrons. That is, he discovered that there are existing charged particles called electrons. And after that, in 1900, Drude proposed a classical free electron theory to explain the properties of metals. Now, he assumed that metals are formed by metallic bonding. Now, metallic bonding means when ions are brought together, their valence electrons are free. That is, when you consider any atom, every atom will try to complete its octet, and whenever metals or elements with two or three valency electrons are brought together, they will form metallic bonding. Now, to complete their octet, they will give away their outermost electrons, which we call as valence electrons. Now, these valence electrons are now not bounded to the atom itself or ion itself, and they are free to move anywhere inside the metal. And therefore, the motion of electron, he assumed that the motion of electron will resemble the motion of gas molecules in a gas. Now, if you look at the screen, the left-hand side is a gas content. Here it is a gas. Whereas on the right-hand side, say this is a gas container. Here, gas molecules are moving in all random directions with all random velocities. While their motion, they are colliding with other gas molecules and also with the walls of the container. Now, this is the gas theory which is proposed by Maxwell Boltzmann. Now, Drude thought that why these electrons cannot be treated as gas molecules, because if you look at this right hand side, it is a metal. Now here ions are regularly and periodically placed, means their positions are relatively fixed, and valence electrons are free and they can move anywhere inside the metal surface. Now, during their motion, the electrons can collide with themselves and also with the ions. And therefore, the motion of electrons inside the metal is similar to that of the gas molecules in a gas or container in a gas. And therefore, Drude proposed that why not to apply the laws of gas molecule to the electron. And this is the assumption or proposition by Drude, and this theory is called as classical free electron theory or Drude's theory, which later on modified by Lorentz. Now, gas molecules have kinetic energies. Similarly, electrons have kinetic energies, and therefore here electrons can be considered as similar to that of gas molecule. and therefore we can call it as a electron gas. Like gas, if it is contains only hydrogen, we can call it as hydrogen gas. If it will contain only oxygen, we call it as oxygen gas. Similarly, in a metal, there are free electrons which are moving in all random directions with all random velocities, whose behavior is exactly same to that of electron, and therefore we call it as electron gas. Hmm. Now, as we are treating electrons as gas molecules, the properties possessed by gas molecules can be assigned to the electron. Now, some of the properties which we can assigning for gas are mean free path, that is the average distance between two successive collisions. Similarly, mean collision time, that is the average time between two successive collisions. And similarly, the average speed, that is average speed of the gas molecule. Similarly, these properties can be assigned to the electron. म्हणजे गॅसमध्ये आपण काय करतो, आता इलेक्ट्रॉन्सला गॅस मॉलिक्यूल म्हणून ट्रीट करतो. जर इलेक्ट्रॉनला गॅस मॉलिक्यूल म्हणून ट्रीट करायचं असेल तर जे गॅस मॉलिक्यूलचे जे प्रॉपर्टीज आहेत, लाईक मीन फ्री पाथ, कोलिजन टाइम अँड अवरेज स्पीड, ह्या सगळ्या प्रॉपर्टीज इलेक्ट्रॉनला सुद्धा असले पाहिजेत. हां, आता ते प्रॉपर्टी जर आपण असाइन केला, आता आपण एक एक प्रॉपर्टी बघूया. रूट मीन स्क्वेअर व्हेलॉसिटी ऑफ इलेक्ट्रॉन गॅस. Now for a unit volume of a metal, similarly for a gas, the pressure exerted by the gas molecules is given by 1/3 rho c bar square, where rho is the density. But now we are treating electrons as gas molecules, and therefore the density of electrons is given by m into n, where n is number of electrons per unit volume multiplied by mass of each electron will give you the density. And c bar is the average speed, which is the now this is the pressure exerted on the walls of the gas container of the gas. Similarly, this is the pressure exerted by electrons. Now, if you consider 1 mole of a metal, it will contain Na, the Avogadro number of electrons. Now here we are assuming that each metal will contribute 1 valence electron. If you assume like that, the number of electrons is equal to Na, whenever the valence is equal to 1. If you consider valence equal to 2, the number of electrons is equal to twice Na, where Na is the Avogadro number, which is the number of gas molecules or number of atoms present in 1 gram, 1 mole of a metal, or 1 mole kg of a metal. Now the general here just 1/3 rho c bar square. If you consider for 1 mole of a gas, rho density is written as m into n. Now n can be for 1 mole of a metal is Na, and Vm is the volume, and therefore it will give you number density of electrons. Now we know ideal gas equation or general gas equation is PV equal to nRT. If you consider 1 mole of a gas here, n equal to 1, and therefore PV equal to RT. It is a general equation. But here we have obtained P equal to 1/3 m Na c bar upon 3 Vm, and therefore if you take Vm on this side, we can write PVm equal to 1/3 m Na c square. Okay. Now if you rearrange this, we can write m c bar square equal to 3 RT upon Na. Just 3 taking on this side, and Na is taken on this side. Now this is equal to 3 kT, because this Rm upon Na is the Boltzmann constant, gas constant divided by Avogadro number. It is the magnitude of Boltzmann constant, and therefore Kb equal to Rm upon Na is the Avogadro number, and therefore half mc square, means by multiplying half on both the sides of this equation, we are writing half m c bar square equal to half into 3 kT, which is the kinetic energy, half mv square. Here v is nothing but the speed of velocity of the gas molecule or electron. Similarly, c is the average velocity of electrons. Okay. And therefore, the average kinetic energy of electrons is given by 1 half m c bar square, which is equal to 3 by 2 kb into T. Now, if you look at this equation, 3 by 2 kb into T, it is a law of equipartition of energy. That is, the energy associated with each degree of freedom is half kT. Now, there are 3 degrees of freedom, and therefore 3 kT upon 3 by 2 kT uh, is the energy associated with electron. Similarly, RMS velocity of electron is defined as root mean square velocity c bar. Now, if you rearrange this equation, we are getting c काढायचं आपल्याला, त्यामुळे हा m इकडे येईल आणि ह्याचा स्क्वेअर रूट 3 kT अपॉन m. kb हा बोल्ट्झमॅन कॉन्स्टंट आहे. प्रत्येक वेळेला kb लिहिलं नाही तर चालतं, k लिहिलं तर चालतं. ऍक्च्युअली तो कप्पा आहे, त्याचा सिम्बॉल असा आहे, हा कप्पा. त्याला बोल्ट्झमॅन कॉन्स्टंट k किंवा kb म्हटलं जातं. Now, this is the RMS velocity. Now, if you look at this equation, RMS velocity is proportional to square root of absolute temperature. Now, for example, if you consider it room temperature, which is say approximately 20 degrees Celsius, C bar will comes out to be this much. Now, we'll define a second parameter called as mean free path. The mean free path, now as here we are considering electrons are moving in all possible directions with all possible velocities, and during their collisions they will collide with other electrons and also with the lattice ions. Now suppose this is path of one electron like this. After collision it has reflected in this direction. Okay, like this. This is one representative. Like this, say one electron is it is traveled from this to this point. Here it has done a collision. It has changed its path. It has changed here, traveled in this direction. Again, it will collide it here with some other particle and again change its direction like this. Okay. Now, after collision, it will travel in certain direction. Means at each collision, its direction will change, and therefore the velocities are different. But the between two successive collisions, certain time is required, and that time we call it as collision time, or it is the time between two successive collisions, or time taken by electron in traveling a distance equal to mean free path. And the distance between two successive collisions is called as mean free path. Okay. Now, if lambda is mean free path and c is the velocity or speed of the electron, then time, general equation, velocity equal to distance upon time, and therefore time equal to distance upon speed. Those formula आहे. Now, we want mean collision time, and therefore average distance between two successive collisions divided by average speed. C bar ची व्हॅल्यू आपण काढलेली आहे 3 kb into T upon m, and therefore if you substitute here we'll get lambda. Now this can be called as relaxation time, or the average time between two successive collisions. Now we have seen what is a theory. म्हणजे Drude's theory म्हणजे काय? We are assuming that free electrons are behaving like gas molecules, and as we are assuming electrons are behaving like gas molecules, they are moving in all possible directions with all possible velocities. They will collide with other electrons and also with the lattice ions, like gas molecules collide with other gas molecules and with the container. Here, instead of container, we have to consider lattice ions and also the surface of the metal. Now, one question will rises here, but because gas molecules are neutral particle, whereas electrons are charged particles. and the motion of charged particle is supposed to constitute the current. But whether a metal without applied electric field can conduct or show current, if you look at, there is no current without any applied electric field. Now, how to explain that? Because gas molecules are neutral, they are traveling in all directions with all possible velocities. They will not, or they will not contribute current, but electrons are charged particles, and the motion of charged particles will constitute the current. But if you look at the direction of motion of electrons, here they are moving in all possible directions with all possible velocities. Means electrons are moving in random direction, and therefore the average velocity of electron in any direction will comes out to be equal to 0. And therefore, the net transport of charge in any particular direction is 0. And therefore, without applied electric field, the charge transport or current through a metal is 0. Because if you consider a electron traveling in this direction, a same other electron will travel in opposite direction, and therefore they will cancel each other's effect, and therefore the net current without applied electric field is 0. But now, if you apply certain electric field to the metal, now this electric field E will exert a force minus E into E on the electron, where minus E is the charge of the electron and E is the applied electric field. Now, because of this applied electric field, most of the electrons will move in a particular direction. Now, as all the electrons are moving in a particular direction, their velocities will remain uncompensated. And this velocity, that is the velocity acquired by electron due to applied electric field, is called as drift velocity. Okay. म्हणजे ज्यावेळेला आपण इलेक्ट्रिक फील्ड अप्लाय करत नाही त्यावेळेला इलेक्ट्रॉनचा मोशन रॅन्डम आहे. म्हणजे ते कुठल्याही डायरेक्शनमध्ये त्या इलेक्ट्रॉन ट्रॅव्हल करण्याची प्रोबॅबिलिटी सेम आहे. म्हणजे फॉर एक्झाम्पल एक इलेक्ट्रॉन पॉझिटिव्ह एक्स डायरेक्शनला गेला तेवढीच त्याची प्रोबॅबिलिटी असते की तो नेगेटिव्ह एक्स डायरेक्शनला जाईल. म्हणून नेट ट्रान्सपोर्ट ऑफ चार्ज हा 0 येतो विदाउट एनी अप्लाइड इलेक्ट्रिक फील्ड. पण जर आपण इलेक्ट्रिक फील्ड अप्लाय केला, इलेक्ट्रिक फील्ड अप्लाय केल्यानंतर काय होतं की त्या इलेक्ट्रॉनवरती मायनस ई इंटू ई म्हणजे इलेक्ट्रॉनचा चार्ज आणि इलेक्ट्रिक फील्ड हे त्याच्यावरती फोर्स ऍक्ट होतं. अँड बिकॉज ऑफ दिस फोर्स electrons will move in a particular direction, and as electrons are moving in a particular direction, their velocities will remain uncompensated, and therefore they will contribute to the current. Okay. Now, if you apply electric field to a metal, is it that we are applying a constant electric field? Means a constant force is acting on the electron, which is given by minus E into E. And therefore, it is an example of uniform accelerated motion. And therefore, it is expected that the velocity of electron should go on continuously increasing. But as it happens, if the velocity of electron goes on continuously increasing, it is expected that for a given applied electric field, means for a constant potential, the current should increase constantly with respect to time. But that doesn't happen, or it is not observed. Initially current is 0, suddenly current will attain a constant value. Now, if we are getting constant value, it is required that, or the system or law requires that there must be some opposing force inside the metal, so that the driving force, here the driving force means the applied electric field, and the opposing force means the damping force exerted on the electron. There should be some damping force acting on the electron, which is compensating the applied electric field. Now, if it is like that, when the driving force and damping force will equals, then we are getting steady electric current. Okay. Now, if you assume that tau is the relaxation time, that is the collision time, that is time between two successive collisions, and Vd is the drift velocity of the electron. Now velocity upon time will give you the acceleration. And therefore mass into acceleration is a force. This equation is force as per the Newton's law, force equal to mass into acceleration. But this is a damping force which is opposing the motion of electron. And this is the applied force on the electron due to the applied electric field. When they are equal, we are getting a steady electric field. Equal and opposite, we are getting a steady electric current. Okay. And therefore, we are equating these two. Now, if you rearrange, we will get equations for drift velocity. Vd काढायचा आपल्याला, and therefore Vd equal to E tau E upon m, म्हणजे हे येईल. That is drift velocity is given by E tau. Tau is the relaxation time. E applied electric field upon mass. तेच इक्वेशन इथे घेतलंय आपण. Vd equal to E tau E upon m. Now, if you assume that the applied electric field is in the direction x direction, म्हणजे जो आपण field apply केला किंवा potential apply केलाय, potential per unit distance is called as field. Then the current density is given by Jx, that is current density in x direction, equal to Ne into Vd, where Vd is the drift velocity, which is the velocity or distance covered by electron in unit time. N is number of electrons per unit volume, and E is the electronic charge. Okay. Now we know expression for Vd, that is drift velocity. If you substitute Vd here, we are getting this one. Ne, this Vd is E tau E upon m. E आहे म्हणून तो N E square tau upon m. Now E, the applied electric field is in x direction, and therefore we can write it like this. Now if you look at this, J equal to some terms multiplied by Ex, and therefore we can write this equation as Jx equal to sigma Ex. Now this equation is nothing but the microscopic form of Ohm's law, because here we are relating current density to the applied electric field, but there are certain terms like number of electrons per unit volume, relaxation time or collision time, mass of the electron, and so on. Or it can be written like this in macroscopic form, म्हणजे measurable quantities मध्ये हे असं लिहिता येतं. Current density equal to conductivity into applied electric field. Okay, means this term we are assumed as sigma, which is supposed to be the conductivity of the metal. Now if you look at this equation, conductivity is equal to Ne square tau upon m. Now resistivity is inverse of conductivity, which equal, and therefore we can write m upon Ne square tau. Okay, this is the equation for resistivity. Okay, now we consider second parameter, next parameter, the relaxation time. We have defined relaxation time as the average time between two successive collisions as collision time. Now, suppose we consider a metal piece and we apply certain electric field to this, and because of that, we are getting a constant current through this metal, say I, and say Vd is the drift velocity corresponding to that current. Vd means the drift velocity of electrons. म्हणजे जर एखाद्या मेटलला आपण इलेक्ट्रिक फील्ड अप्लाय केलं नाही तर इलेक्ट्रॉन्स कशा असतात, रॅन्डम मोशन मध्ये. दे आर ट्रॅव्हलिंग इन ऑल पॉसिबल डायरेक्शन्स विथ ऑल पॉसिबल व्हेलॉसिटीज, and hence the net current contributed by those without applied electric field is 0. But if you apply certain electric field, most of the electrons will travel in a particular direction, and because of that we are getting a uncompensated electric field current. Now corresponding to that current, say the drift velocity of electrons is Vd. Now if you switch off the current, म्हणजे हा करंट मी जर ब्रेक केला तर काय होईल? Now ultimately the electrons will again start moving in random direction and current will become 0. But whether it will come suddenly or it will take certain time. Now, when it is observed that when you remove the electric field applied, say at time t equal to 0, we have removed. At that instant, say Vd of 0 is the drift velocity, म्हणजे electric field असतानाचा. Now, as you remove the electric field, the electrons will, the motions will become random, and therefore they will try to move in all possible directions with all possible velocities. And the time required for drift velocity to reduce to 1 by e times its maximum value. आता ही आहे ते maximum value आहे, that is the drift velocity in presence of electric field. Now, when you remove electric field, the drift velocity will reduces, and ultimately it will comes out to 0. Now, the time required for drift velocity to decay 1 by e times its initial value is called as relaxation time. आता वेगवेगळे डेफिनेशन देतोय आपण. Relaxation time is the time required for drift velocity to decay 1 by e times its initial value or its maximum value. Now, as you consider, the damping force acting on electron is m Vd upon tau minus m Vd upon tau, and therefore by Newton's second law of motion, that is rate of change of momentum equal to the applied force, we can write this equation. D by dt of m into Vd means m into V is momentum, and therefore rate of change of momentum equal to the damping force, which is minus m Vd upon tau. Okay, again the same equation I have considered here, m Vd upon d by dt of m Vd equal to minus m Vd upon tau. Now m common and therefore cancels, and therefore we can write d Vd upon dt equal to minus of Vd upon tau. Now if you rearrange, we can write हा d t इकडे घेतला आणि हा Vd इकडे घेतला, interchange केला तर हे येईल. Now if you take logarithm, we can write ln of Vd equal to minus of t by tau plus c, where c is constant of integration, which can be found out by applying boundary condition. Say at t equal to 0, Vd is equal to Vd of O. If you substitute here, t equal to 0 म्हणजे हा term झाला 0, and therefore c equal to हे येईल. This is equal to c. Okay. Now if you substitute this c here again, ln of Vd equal to minus t by tau plus ln of Vd of 0. Now if you rearrange, म्हणजे हा ह्या साईडला घेतला तर तो मायनस येईल इकडे घेतल्यानंतर, पण तो लॉग मध्ये घेतल्यानंतर डिनॉमिनेटर येतं ln of Vd upon Vd of 0 equal to minus t upon tau, and therefore Vd equal to Vd of O e raised to minus t upon tau. And therefore drift velocity, or this equation will give you the variation of drift velocity with respect to time. And therefore as per this equation, we can say that the drift velocity of electron will reduces exponentially with respect to time after removing the electric field. Now if you assume t equal to tau, then Vd equal to Vd of O upon E, which is the definition for relaxation time. It is the time required for drift velocity to decay 1 by E times its maximum value. Okay. Now we consider the collision time. Collision time is the time between two successive collisions, or average time between two successive collisions. Now if you assume tau is the collision time, then the number of collisions per unit time is 1 upon tau. कारण एका collisionला लागणारा time किती आहे tau, and therefore the number of collisions per unit time is 1 upon tau, and therefore the number of collisions in time dt can be written as time into number of collisions per unit time. ह्या दोन्हींचा प्रोडक्ट, हे आणि टाइमचा प्रोडक्ट म्हणजे हे येईल. This is the number of collisions per in time dt. Okay. Now if you assume, consider a electron. आता ह्यातला कुठलाही एक इन्स्टंट आपण अज्युम करू शकतो. समजा मी हा इन्स्टंट अज्युम केला. जर इथे एक इलेक्ट्रॉन आहे, त्याच्याबरोबर हा इलेक्ट्रॉन कोलाइड होणार आहे, and therefore before collision, the electron is traveling in a particular direction, and suppose the velocity of that electron is v_d, drift velocity. This is the velocity of the electron before collision. But after collision, electron can travel in any direction. That is, it can travel in all possible directions, and therefore the average velocity, say at some instant it will travel in this direction, some instant it will travel in this direction, some instant it will travel in this direction, and so on. Now, if you take the average of all these, the velocity after collision will comes out to be equal to 0. But velocity before collision is v_d, and therefore change in velocity during a collision is velocity after collision minus velocity before collision. Now velocity after collision is 0, and the v_d is the velocity before collision, and therefore minus v_d is the चेंज इन व्हेलॉसिटी पर कोलिजन. म्हणजे एकदा कोलिजन झाली तर एवढी चेंज होते. पण एका सेकंडमध्ये किती कोलिजन्स होतात? 1/टाऊ. कारण एका कोलिजनचे टाइम किती आहे? टाऊ. एका सेकंडमध्ये त्यामुळे 1/टाऊ होतील. आणि एका कोलिजनमध्ये किती व्हेलॉसिटी चेंज होते? -v_d. अँड देअरफोर द रेट ऑफ चेंज ऑफ ड्रिफ्ट व्हेलॉसिटी, which is the change in drift velocity per unit time, can be written as dvd by dt equal to minus vd/tau, because 1/tau is the number of collisions per unit time, and minus vd is the change in velocity per collision. म्हणजे प्रत्येक कोलिजनला -vd एवढा चेंज होतो, आणि 1/tau एवढी कोलिजन्स आहेत युनिट टाइम मध्ये, and therefore the total change in drift velocity per unit time is minus vd/tau. Now, if you look at this equation is, here we are defined tau as collision time, which is the average time between two successive collisions. But earlier we have derived this equation where tau, this capital Tau, we have defined as relaxation time. It is the time required for drift velocity to decay 1/e times its maximum value. But if you look at these two equations, these two are identical. कारण dvd by dt लेफ्ट हँड साईडला दोन्हीच्या -vd आहे, इथं टाऊ इथं टाऊ आहे, फक्त सिम्बॉल इथं स्मॉल वापरलाय, इथं कॅपिटल वापरलाय. बट बाय डेफिनेशन स्मॉल टाऊ इज collision time we have defined, and capital Tau is the relaxation time. But if you compare these two equations, we can say that relaxation time is same as that of collision time, and therefore we can confirm that relaxation time and collision times are same. Similarly, we can define the mobility. Now, without applied electric field, electrons are moving in random directions with random velocities, and therefore the average drift velocity is 0. But if you apply certain electric field, electrons will travel in a particular direction, and therefore they will have a uncompensated velocity called as drift velocity. Now the drift velocity per unit applied electric field is called as mobility. Mobility is defined as drift velocity per unit applied electric field. Now we know equations for drift velocity, relaxation time, and therefore mobility can be defined, which is defined here, vd/e can be written as vd चं इक्वेशन इथून आणि टाऊचं हे सबस्टिट्यूट केलं तर ते येईल e/tau/m, which can be written as sigma/n into e, and therefore if you rearrange this equation, sigma equal to ne mu, that is electrical conductivity equal to n number of electrons per unit volume into e charge of each electron multiplied by mobility. Similarly, from this equation, if you rearrange, we can write this equation. Sigma equal to n आणि n हा इकडे घेतला तर n e square आणि tau/m, and therefore we can write this equation. We know that tau equal to lambda/c, and c bar equal to √3 kT/m. म्हणजे जर हे आपण इथं सबस्टिट्यूट केलं तर tau हे येतं. Now if you substitute here tau, we can obtain expression for sigma as this one. And if you rearrange, means if you take the inverse of that, we can write equation for resistivity. Inverse of conductivity is resistivity, which has been written. Okay. Now, resistivity is proportional to, as per this theory, square root of 3m kb into T upon n is square lambda. Now, k, m, lambda, all these are constants, and therefore we can say that resistivity is a linear function of square root of temperature, or resistivity is proportional to square root of temperature. Now, this is a prediction as per the classical electron theory proposed by Drude. Okay. That is, resistivity is proportional to square root of absolute temperature. But practically, resistivity is proportional to absolute temperature and not proportional to square root of absolute temperature, and therefore the classical theory fails. Means, by considering electrons obey gas molecules, and if we apply classical Maxwell-Boltzmann statistics to electrons, we can explain Ohm's law, but it will fail to explain the variation of resistivity with temperature. Now, one more property possessed by metals is Mathesin's rule, which states that resistivity of a metal is sum of two components. One, a constant term, which is dependent on temperature, and one dependent on uh, constant term, which is independent of temperature, which is due to, this is a constant term, which arising due to collision of electrons with the impurities. Okay. Now, as per this theory, the resistivity of metal will show these two curves. This is a constant term, and this is a temperature dependent term. Okay. Now, this will arises due to interaction of electron with the impurities. Now, number of impurities is very small, and therefore their contribution is supposed to be constant or independent of temperature. Whereas the resistivity due to collision of electrons with the lattice should be, he assumed that it should vary, is a linear function of temperature. Okay. Now, corresponding to two parameters, that is relaxation time or collision time, there are two, and therefore we can split rho into two terms. म्हणजे आपण जर क्लासिकल थिअरी कन्सिडर केली तर काही म्हणजे ओहम्स लॉ आपण एक्सप्लेन करतो, पण काही म्हणजे वी आर नॉट एबल टू एक्सप्लेन द व्हेरिएशन ऑफ resistivity with temperature. Now, there are some other parameters which are shown by metals, but this theory fails. Now, these are specific heat, temperature dependence of conductivity, dependence of electrical conductivity on electron concentration. म्हणजे इथं इलेक्ट्रिकल कंडक्टिव्हिटी मध्ये सगळीकडे आपण इथं इक्वेशन येतं n इथं. Conductivity is proportional to n. Electrical conductivity is proportional to n. N is the number of electrons per unit volume. Means this theory will expect that more the number of free electrons, more is the conductivity. Now, if you consider metals with monovalency, bivalency and trivalency, monovalency म्हणजे ज्याच्या व्हॅलेन्सीमध्ये एक इलेक्ट्रॉन असतं, बायव्हॅलेन्सी म्हणजे ज्याच्या व्हॅलेन्सीमध्ये दोन इलेक्ट्रॉन असतील, आणि ट्रायव्हॅलेन्सीमध्ये त्याचे व्हॅलेन्सी ऑर्बिटमध्ये 3 इलेक्ट्रॉन्स असतील. जर मोनोव्हॅलेंट, बायव्हॅलेंट आणि ट्रायव्हॅलेंट मेटलची कंडक्टिव्हिटी जर कन्सिडर केला आपण, फॉर एक्झाम्पल गोल्ड इज ए मोनोव्हॅलेंट, फेरस आयरन इज अ ट्रायव्हॅलेंट, कॉपर इज अ बायव्हॅलेंट. ह्या तिन्हींची जर कंपॅरिझन केलं आपण, ह्या थेरी काय सांगते, iron which is trivalent should be good conductor, then copper which is bivalent, and conductivity of copper should be better than gold which is monovalent. But practical results are opposite. Gold is better conductor than copper, and copper is better conductor than iron. Means the conductivity is not directly proportional to number of electrons. It is independent. Depends upon other parameters, and therefore classical theory fails to explain some parameters. Now we consider some of the major parameters where classical theory will fails to explain. One of them is heat capacity of electron gas. Hmm. Now, when you heat a metal, all the electrons, as per this theory, all the electrons will take heat or energy and they will get excited, or the energy of electrons will increases. Now, according to law of equipartition of energy, the the energy with associated with each degree of freedom is half kT. केबीच्या वेळेला प्रत्येक वेळेला आम्ही केबी म्हणत नाही, के म्हणतो. Energy associated with each degree of freedom is half kT. Now there are 3 degrees of freedom, x, y, z, and therefore the energy possessed by each electron is 3 by 2 k into T. Now, if you consider 1 mole of a metal and assuming that each atom is contributing 1 electron, म्हणजे monovalency आहे असं आपण assume केलं, तर there are n a number of electrons in a 1 mole of a metal, and therefore the energy possessed by electrons in a 1 mole of a metal is 3 by 2 na kb into t. ओके, कारण प्रत्येक इलेक्ट्रॉनची एनर्जी काय आहे, 3 by 2 kT आहे, आणि तिथे इलेक्ट्रॉन्स किती आहेत, ॲव्होगाड्रो नंबर एवढे आहेत 1 मोल मध्ये, अँड देअरफॉर दिस इज द टोटल energy possessed by electron. Now, if you heat the metal, electrons will absorb heat. Of course, lattice and electron both will absorb, but the contribution to due to lattice is already well known and it has been explained. Now, the contribution due to the electrons we are considering. Now, specific heat is by definition, it is the heat required or the energy required to raise the temperature of 1 mole of a metal by 1 degree Celsius. Okay, and therefore du by dt, the rate of change of energy with temperature, is the specific heat. आता u इथं आहे, त्याचा आपण du by dt घेतला तर तो येईल 3 by 2 na kb, but na kb is the gas constant, we know that, and therefore we can write 3 by 2 is 1.5 and rm is the gas constant. Now, all these are constant, na kb is constant or rm is a constant, and therefore specific heat of electron or contributed by electrons will comes out to be, in general it is 1.5 rm or 12.5 kilojoules per kilomole per degree. But practically it has been proved that the electronic contribution to specific heat is about 100 times smaller than this value. म्हणजे तो simply point म्हणजे ह्याच्या डिवाइड बाय 100 करायला लागेल, ती प्रॅक्टिकल व्हॅल्यू आहे. म्हणजे हे जे काढतोय आपण इथं थेरॉटिकल व्हॅल्यू आहे आणि प्रॅक्टिकल व्हॅल्यू ह्याच्यापेक्षा 100 टाइम्सनी लेस आहे. मीन्स क्लासिकल थेअरी विल प्रिडिक्ट specific heat about 100 times larger than the practical value. Because here we are assuming that all the free electrons are contributing to the specific heat. म्हणजे हे काय तर चुकतंय आपलं, and therefore here this classical theory fails to explain the electronic contribution to the specific heat of metals. Okay. This is one of the failure. Now, the second failure of classical theory is it fails to explain the mean free path possessed by metals. Now, as per this theory, a classical theory, the resistivity, which is 1/1 conductivity, is given by m upon n e square tau. Now, for example, if you consider copper, for which the number of electrons per unit volume is 8.5 into 10 raised to 28 per meter cube, and resistivity is 1.69 into 10 raised to minus 8 Siemens, which we call as ohm meter. Relaxation time will comes out to be 2.14 into 10 raised to minus 14 seconds. Therefore, collision time equal to lambda upon c bar, and therefore lambda equal to tau into c. Tau we have obtained here. C already mark काढलाय. If you calculate that, it will comes out to 28.5 Armstrong unit. Means mean free path of electron in copper is 28.5 Armstrong unit. But this is again very small, roughly 5 times small than the practical value. And therefore, again, the classical theory fails to explain the larger value of mean free path of electrons. Now we move to the third point, that is Weidmann-French law. Okay. Now Weidmann-French law states that the ratio of thermal conductivity to electrical conductivity is a linear function of temperature. That is sigma T upon sigma is proportional to T, absolute temperature. Now we'll consider how it will explain, or how the classical theory can explain. Now just consider a piece of metal. Say the mean free path is lambda. We consider three sections of metal, say these three sections at temperature say T, T plus dt up dou T upon dou x into lambda, T minus dou T upon dou x into lambda, means here temperature is low and here it is high on one end, and we are considering three regions separated by a mean free path. Now here we are assuming a distance equal to mean free path because we are assuming that electron will jump from one to another region within one jump. Now corresponding to temperature, there are energies, say E minus dA upon dx into lambda, E at temperature T, similarly E plus dA upon dx. Now if a electron jumps from region A to region B, electron at region A has higher energy. If it go to region of lower energy, it will gives there its energy and go to ground state. Similarly, if a electron which is at lower energy go to higher region of lower energy, it will goes there and get excited. म्हणजे हायर रिजन एनर्जी रिजनचा इलेक्ट्रॉन जर लोअर रिजनला आला, लोअर एनर्जी रिजनला, तर तो आपली इलेक्ट्रॉन त्या रिजनला देईल आणि त्या रिजनची एनर्जी वाढवेल. तसंच उलट सुद्धा पॉसिबल आहे. समजा लोअर एनर्जी रिजनचा एक इलेक्ट्रॉन हायर एनर्जी रिजनला आला, तर तो त्याची एनर्जी त्या हायर रिजनला देईल आणि त्याची एनर्जी वाढवेल. Now, as we are dealing with kinetic theory of gases, we are applying kinetic theory of gases to metals or electrons. Now, there is equal probability of traveling electron in all possible directions, and therefore, the probability of traveling electron in one direction or number of electrons flowing through unit area in unit time is n c bar by 6, where c bar is average speed, n is number of electrons per unit time, and there are 6 possible directions, like say positive x, negative x, similarly positive y, positive z, negative z, like this 6 directions are there. Now this is the number of electrons crossing per unit area per unit time. This is the energy transferred by these electrons. Now electron from higher energy will go to lower energy and also transfer energy. Similarly, electron from lower energy will go to higher energy and that will transfer energy, but in opposite direction. And therefore here we are considered minus minus, which will again comes out to be plus. And therefore n c bar by 6 into lambda, this lambda, d by dx is the energy transfer per unit area per unit time. But by definition, if you assume that this energy difference is only due to temperature difference, then this energy transfer can be related to thermal conductivity and temperature gradient. कारण 3 रिजन जे आपण अज्युम केलेले आहेत, किंवा हे हायर रिजन, हायर टेम्परेचर रिजन and this is a lower temperature region, means there is a temperature gradient from one region to the another. And therefore, due to temperature gradient, the heat transfer is given by thermal conductivity into temperature gradient. dt upon dx is the temperature gradient and sigma t is the thermal conductivity. Now if you rearrange this equation, इथं dA upon dx आहे, त्याला आपण काय करतो, dA upon dt into dt upon dx, फक्त dt मल्टिप्लाय आणि डिवाइड केला. हे केल्यानंतर काय होईल, हा टर्म dt upon dx आणि हा टर्म निघून जाईल. And therefore we can write n c bar by 3 into lambda d upon dt, we can write 3 by 2 kt, because E equal to 3 by 2 k into t. And therefore d by dt is equal to 3 by 2 kb येतं. तो इथं आपण सबस्टिट्यूट केला equal to sigma t. But this is sigma t. Now c bar here we know c bar equal to this value. If you substitute here, we are getting sigma t. Similarly, electrical conductivity is given by 1 upon resistivity, which is equal to n e square lambda upon square root of 3m kb into t. Now, if you take the ratio of this term and this term, we are getting this term. हे करायचं, हे डिवाइड बाय हे आहे, म्हणजे ह्याला मल्टिप्लाय केलं की न्यूमरेटरचं डिनॉमिनेटर आणि डिनॉमिनेटरचं न्यूमरेटर येतं ह्याच्यात इकडे. नाउ इफ यू सिम्प्लिफाय, we are getting like this: sigma t upon sigma equal to kb upon 2 3 kb t upon e square. Okay. Now if you rearrange, we are getting like this. हे फक्त काय केलंय, 3/2 आहे तो घेतला, kb आणि kb square आणि e square आहे, kb upon e square into t. Now if you equate this term equal to L, just we are replacing kb upon e square into 3/2 by number, say L, which is called as Lorentz number. Then we can write sigma t upon sigma equal to L into t, or sigma t upon sigma, that is ratio of thermal conductivity to electrical conductivity, is proportional to absolute temperature, which is the statement of Weidmann-Frenzel law, and therefore classical theory will predict that Weidmann-Frenzel law is true. But now if you consider this constant L equal to, as per this equation, L is coming out to be 3/2 kb upon e square into t. This is the theoretical value of K, L, the Lorentz number, 1.2 into 10 raised to minus 8 watt ohm per Kelvin square. But if you consider the practical value, say for example copper at 27 degrees Celsius, the thermal conductivity is 386 and electrical conductivity is this one. If you take that ratio, it will come out to be 2.26 into 10 raised to minus 8 watts ohm per Kelvin square. Means this is the practical value and this is the theoretical value. Means theoretical value is about half the practical value, and therefore again classical theory fails to explain the Lorentz number. Classical theory will give you the Weidmann-Frenzel law, but the proportionality constant, the magnitude of proportionality constant is smaller than the practical value, and therefore again the classical theory fails to explain the Weidmann-Frenzel law or Lorentz number. One more aspect which classical theory fails to explain is the paramagnetic susceptibility of the materials. As per this theory, it is expected that susceptibility is a inverse function of temperature. म्हणजे जसं टेम्परेचर वाढेल तसं susceptibility हा कमी व्हायला पाहिजे होता. But for most of the metals, paramagnetic susceptibility is found to be independent of temperature. म्हणजे तो टेम्परेचर बरोबर व्हेरी होत नाही, and therefore classical theory will fails to explain again. म्हणजे बेसिकली 5 पॅरामीटर्स मध्ये क्लासिकल थेअरी फेल होते. वन इज, पण तो एक आहे तो रेजिस्टिव्हिटी इज प्रोपोर्शनल टू स्क्वेअर रूट ऑफ ॲब्सोल्यूट टेम्परेचर क्लासिकल थेअरी प्रमाणे, बट प्रॅक्टिकलिटी इज प्रोपोर्शनल टू टेम्परेचर, तो एक आहे. In spite of that, there are 4 basic failures of classical theory. These are heat capacity of electron. As per the practical or the predicted heat capacity is about 100 times larger than the practical value. It will predict smaller mean free path. The practical values are about 5 times larger than the theoretical value. Weidmann-Frenzel law. This theory will predict Weidmann-Frenzel law, but the Lorentz number which will comes out to be is about half the practical value. And lastly, the paramagnetic susceptibility. Now here we complete the classical theory. Okay, sir. हॅलो सर, कंटिन्यू करायचं का थांबवलं तर चालते? कारण एक मी थेरी संपवली आहे, 1 तास सांगितलं होतं म्हणताना एक थांबवतोय.
ओके सर.
हा एंड करायचं ना.